we begin anything else, in case I forget, I'm instructed to draw your attention to the list on the blackboard. So this class will end at 6:30. And then you have an hour to eat before coming back to Bonnie Walker, 2 floors down. David Beaver assures me that those who do not attend Bonnie Walker's talk will be excluded from the remainder of the proceedings. At 8:30 there's a party with light refreshments in Medici, the Café Medici on Guadeloupe. The refreshments are light, so those of you who need more than light refreshment need to do something more substantial between 6:30 and 7:30. Well, I'm Mark Sainsbury, here's Hans Kamp. We're doing this class jointly. I'm going to start off by just a sort of little warm-up, get you in the mood for thinking about vagueness. And then in the second part of this class, Hans is going to start talking about model theoretic approaches to language in general and to vagueness in particular. In the first part of tomorrow's class, Hans will continue that more technical and formal work, including showing how supervaluational approaches can be applied to languages containing vague expressions. And towards the end of that class, I'll just raise some very general questions about supervaluational approaches, some general philosophical questions, sort of methodological questions about supervaluations. On Wednesday, we start very explicitly our official topic, which is trying to understand how vagueness and context are related. Everyone believes that vague expressions are context sensitive. There isn't any discussion about that. The discussion concerns how context affects vague expressions, and in particular whether there's something distinctive about the way in which context does that. So that topic gets its first explicit, or fully explicit in a way, discussion on Wednesday, when I'm going to introduce 2 quite well-known contextualist approaches, one by Diana Raffman from her paper in 1994, one by Delia Graf, her paper in 2000. The division of labour between Hans and myself, other than the fact that Hans has to do the hard stuff and I do the easy stuff, but other than that, the division is that Hans is going to defend a contextualist approach, and I'm going to defend an anti-contextualist approach. That's just to give the class a kind of dynamic. So in 1981, Hans wrote a paper called The Paradox of the Heap, in which he offered a contextualist approach. He is now that paper's severest critic, but he's nonetheless going to develop on Thursday contextualism, starting with a discussion of that early paper of his. On Friday, we have the final, what should we call it, the final tournament. We each try and present the case for our allocated positions as best we can. So I'll go first and try and do my best for the anti-contextualist, and Hans will go second and do his best for the contextualist. We welcome questions at any point. Just stick up a hand. We ask in advance to be forgiven if we don't answer the questions very fully. We do have quite a lot of material that we're planning to get through. Well, I think that's the introductory material done. Was there anything else I should be saying of that general kind? Okay. Good. So let's start. What is vagueness? So we're only going to talk about vagueness in language. There are a lot of other things that are often said to be vague, like mountains or propositions or conditions or stipulations or whatever. Various things said to be vague. We're just going to confine ourselves to vagueness in language. And the linguistic categories that we'll be concerned with, following what's been historically the case, are the category of predicates, as logicians tend to call them. So those are adjectives, especially adjectives and common nouns. Tall, bald, red, heat, tadpole. If you were giving a full account, there many other categories should be added. We certainly want verbs, adverbs, quantifiers like runs, now, quickly, near, at, probably, many, few. There's vagueness that seems to affect just about every category of expression that I can think of. And then there's an issue which actually is an interesting one. It's one of the many issues we're just going to have to leave to one side, is how the vagueness of an expression affects the vagueness, or otherwise, if that's the right way to characterize it, of a whole sentence. If one was trying to give a philosophical introduction to the nature of vagueness, one would probably start by contrasting vagueness with a number of other properties. And this would be quite a useful thing to do, but we're not, in fact, going to do it. I'm just going to indicate some things one might contrast vagueness with, because I really do think it's worth thinking about. Ambiguity is a standard one, although if you consider Kip Fine in his 1975 paper, he said vagueness is ambiguity on a very large scale, on a major scale, so maybe there isn't a contrast there, but that itself, of course, would be an interesting discovery. Imprecision is a clear candidate, indefiniteness, fuzziness, uncertainty, inexactness, looseness, underdetermination. I've got one more there, unclarity. So there's a range of contrast. Anyway, I'm just going to leave you guys to reflect on those contrasts. But I do, mentioning Fine, 1975, reminds me of one preliminary topic that I should have mentioned, which is how do you access this reading? So I realize you're much too busy, probably, to read anything. But well, what I've done so far is to send, but I know it hasn't left my computer. My computer's little wheel has been revolving for nearly 24 hours now, trying to send stuff to the NASSLLI organizers. But what I did do before I knew the NASSLLI organizers were going to have a site was to make a little Dropbox folder, and I sent it out to the email list. And in fact, to some members of the email list, and I apologize for this, I sent it twice. So I put on that the things that are harder to get hold of, things in collections as opposed to journal articles. And these are the three things that are in the Dropbox. Just email me if you haven't got the link to it. I've put the two Kamp papers that are hard to get hold of because they're in collections, 1975, the one about adjectives, and 1981, the paradox of the heap. And then I've put, and so you have to treat this with a certain amount of circumspection, I've put the whole of Shapiro's book, Vagueness, in context. Please email me if you want more stuff made available. I have a very large electronic library on vagueness, so if we mention something and you want it, just email me. Okay, so we're going to think of Sorites' susceptibility as the critical feature that is going to occupy us and serve as a at least temporary definition of what vagueness is. So we need to start by saying what it is for an expression to be Sorites susceptible. So I think of Sorites susceptible as like being susceptible to coals or something. You don't necessarily catch it. So something could be Sorites susceptible without actually generating a Sorites paradox. So that contrast for us is very important. So here's the definition for a predicate P of what it is for it to be Sorites susceptible. You need a comparative relation, more or less R than, which can, in principle, give rise to a Sorites series. So a Sorites series is a series of objects, each slightly more, or alternatively less, R, than its predecessor, whose first member is P, so it falls under the predicate, whose last member is not P, and where adjacent pairs are so similar in point of this relation that it seems arbitrary to regard one as P and the other as not P. So please focus on the words in blue. So they're not theoretical, they don't generate paradox. They don't tell you that the other one has to be P2 or anything. Indeed, they don't address anything, first of all, they don't address the facts of the matter because they only address how things seem. And secondly, they just say something purely epistemic or pragmatic that it would be arbitrary to make a distinction. So they don't tell you that there's no distinction there. So that's what it is to be Sorites susceptible. It's completely innocent from any threat of paradox as such, just as it stands as a definition. So what is a Sorites paradox? Well, a Sorites series of objects can give rise to a Sorites paradox if we elevate what we had before in the definition of Sorites susceptibility, namely the arbitrariness of making a discrimination with respect to P, or indeed it should really be the apparent arbitrariness of doing that. If we elevate that to there really being no difference in respect of P. So then you'd get what people standardly refer to as the inductive premise. For everything in this series, if one member of the series is P, then the next one, X prime, is also P. So it's a very standard way of writing out what's problematic or what's soritical, it's genuinely paradox-inducing, that appears to be a property of Sorites series of objects. The use of this X prime notation is of course not, that's not authentic, it's not part of any familiar formal language, and Hans is going to say something about that and indeed engage in a proper specification, a proper formal specification of various ways in which Sorites paradoxes can be set out in an authentic way. This is just a rough and ready start. So now go back to our Sorites series. We've got endpoints that differ in respect of P. So maybe the first object, x sub 0, is P, and the last object is not P. And then we've got this inductive premise, which will enable us to derive that the last object is also P. One way to do it is by taking a series of conditional instances of the generalization and then engaging in various steps of modus ponens, and you get a kind of domino effect, and you end up saying that the last object is P, whereas it's also one of the premises that the last object is not P, so there's contradiction. So, as I stressed, being Sorites susceptible does not entail being soritical in the sense of generating a Sorites paradox. But, of course, the two things are close. And one of our jobs is to explain how they can be properly separated. There can't really be soritical expressions, because soritical expressions are ones that, if they exist and are genuinely soritical, they entail that there are true contradictions. But there aren't any true contradictions, so there aren't any soritical expressions. So this is the space in which we have to operate. We've got, it seems arbitrary to regard x as P and x prime as not P. That's the definition of what it is for some objects to be involved in a Sorites series, and therefore to be Sorites susceptible. And then the problematic place, the place we must not end up, or so it seems, is with the inductive premise that if any member of the series is P, then so is the next member. So that's our job, to try and give a non-soritical account of the arbitrariness. And so context is one of the ways in which one can endeavor to do that. I thought it would be a shame to discuss Sorites paradoxes without actually looking at something soritical. Here are a couple of quotes. From one's first from Wright and the second from Raffman. Wright says, "It's familiar that we may construct a series of suitable homogeneously colored patches." I slaved away and constructed them in such a way as to give the impression of a smooth transition from red to orange. I went a bit further than that, where each patch is indiscriminable in color from those immediately next to it. It is the non-transitivity of indiscriminability which generates this possibility. Raffman says that a phenomenal Sorites series is a series of stimuli in which neighboring items appear the same, but the endpoints appear different at a given time to a perceiver who proceeds along the series, giving each pair of stimuli a good straight look. And so we might just do that. There's a pair. I challenge anybody to detect visible difference other than the fact that one's to the left and one's to the right. And it's really, I personally find it impossible to find a chromatic difference. And the same is true even in the cases which I think clearly not red, the clearly orange cases, and in the yellow cases. So I think this is useful to bear in mind when you're thinking about those conditionals. here we are. We know exactly what's going on. Nothing is hidden. Well, nothing is hidden. But if we take any pair and we say, consider the material conditions, just a material conditional. If the one on the left is red and the one on the right is red, aren't we going to say that's true of each pair? Anyway, if we do that, things go badly for us, so we have to avoid that temptation. One of the discussions that comes up, and Hans indeed will be spending a little time on this, but it's an aspect of the discussion that comes up in this connection, is the relation between positive predicates, or adjectives like tall, and their related comparisons, like less tall than is less tall than. So in a series of people starting with a giant and ending with a midget, it may be that each is only very slightly, for example, a millimeter less tall than the predecessor, and then it seems arbitrary to regard a member of the series as tall, yet its successor is not tall. And so the semantics for tall need to prevent it from becoming theoretical. But the question here is, should we take the positive tall, or the comparative taller than, or less tall than, as primary? And there's people who have encountered anything in linguistics will know there are two views to be taken on that issue. And I think we will have at some point a little bit to say about that. It's also worth remembering that when one is doing that, one needs to make room for the fact, and you came across this fact the other day, it's not fantastically super relevant, I have to confess, but it struck me as rather a surprise, so I thought I'd pass it on. That even though taller than is not vague, or at least not very vague, tall compared to is vague. So tall compared to someone of exactly 6 feet. Will 6 1/2 do? 6'6" certainly does it, but that's vague. So it's odd. They're both comparative. They both involve comparison. One's an explicit comparative and the other is not. And they seem to differ in whether they're vague or not. Sometimes we don't get the kind of relation we have between tall and taller than. Sometimes the underlying relation that will get things into a Sainsbury series involves something with no apparent linguistic connection to the vague predicate in question. So for heap, it's the number of grains and maybe something to do with their arrangement that constitutes the underlying relation, which offers up Sainsbury's series of objects. People often refer in these discussions to tolerance principles. Now I have to say there's a lot of sort of confusion about the history and the use of this expression. So I'm going to do a little bit of setting straight here. Crispin Wright first introduced the phrase tolerance principle, and here are his words more or less. P is tolerant with respect to phi if there is some positive degree of change in respect to phi. Phi is the underlying relation, it's like the R in my definition, insufficient ever to affect the justice with which P is applied to a particular case. Now, some people think that Wright is using the tolerance principle as something that he, in some sense, endorses or feels that we're bound to endorse if we allow that there are vague predicates. But what he says is that such principles are palpably incoherent, and they entail the bad thing, the inductive premise that for all x, if x is p, then x prime also is p. And the discussion on the very same page, in fact, contains the following warning, which I think is very apt and we should all remember. Don't confuse the fact that given that we have accepted that x is p, we've accepted that as true, we are never required to count the claim that the next one is p as false. We mustn't confuse that with the incoherent rule that we are required to count the next one as true. So the incoherent rule in red is somewhat like the inductive premise. It's something like what he's called the tolerance principle. So Wright is taking the tolerance principle as something to be avoided. Some people, some authors you'll find take it differently. They take it as something that if there really are vague predicates, it's something you ought to accept. So what we have to do is to explain what's true, namely that if we've counted px as true, we're never required to count px prime as false. We should explain why that's true and how it's true, while also explaining that the bad guy, the IP, the inductive premise, is false. Higher order vagueness and gap principles. One way to think about vagueness is to, and this is really the starting point for supervaluational approaches, is to think that there are the positive cases for predicate, that's the positive extension, then the negative cases, the cases where the predicate doesn't apply, that's the negative extension, and then there's a gap in between of remaining cases, a non-empty penumbral extension as it's called. So then you get a kind of gap in the Sainsbury series. There's a gap which separates the positive cases for the predicate from the negative cases for the predicate, and perhaps that in some way does justice to vagueness, is the thought. And that's how it's done in supervaluational theories with these three extensions, positive, negative, and penumbral. But if these extensions are sharp, so if they're ordinary sets, which is, of course, all any sort of classical model theorist has to work with, they're just sets, it's just a part of set theory, you seem to have made no room for higher order vagueness, the vagueness concerning where the first borderline case occurs. So you've got your gap, let's suppose. There's some cases which are neither in the positive extension or in the negative extension, but here's a question that you might ask. Which is the last member of the positive extension before we get into the penumbral area? If we've only got sets to deal with, it looks as if you're going to have a sharp line there, and arguably vagueness precludes that kind of sharp boundary. So higher order vagueness must never be forgotten, and no account of vagueness is going to be adequate unless it answers that question. Wright considered a principle that might give you gaps without the picture, the bad picture that gaps may come with. He suggested that perhaps we characterize the vagueness of a predicate P in the following way, using the capital delta as an abbreviation for its definite that. In every object in the Sainsbury series, if one is definitely P, then it's not the case that the next one is definitely not P. So this is not immediately theoretical. This doesn't, you can't derive paradox in the straightforward way you can from the inductive premise. And that's for the simple reason that the consequent here doesn't have the right form to mesh with the next conditional, with being the antecedent of the next conditional. Since to have straightforward varieties, you need the antecedent and the consequent of the conditional to have the same form to get the domino effect when you're doing modus ponens. Wright actually, in the article in which he discusses this, suggests that given some seemingly quite modest principles regarding definiteness, or the definitely operator, the delta operator, we'll still get a contradiction. And he's made, that was a long time ago he argued that. He's maintained the view that there's a problem of higher order vagueness right up until very recent work. Here's a feature which I think is important about vagueness, and that is that some boundaries are permissible. In certain circumstances, we can, with no affront to semantic propriety or to the facts, make some kind of sharp local ruling. So in a paper of mine from a long time ago, I gave an example of a paint shop proprietor who was selling paints of various colors. Indeed, he had a very good selection of colors, but he wanted to arrange them on shelves, sort of sloping, I imagine the shelves sloping downwards, and so he had to draw a line between the reds and the oranges. He's going to maybe put the reds on the top shelf, and then there'd be a label saying reds. Yeah, and then put the oranges on the next shelf, label saying oranges. And this seems a completely legitimate thing to do. It doesn't seem to raise any sort of hackles or make us think he's been stupid or illogical or committed to any sort of contradiction. Even if the least red is barely distinguishable from the reddest orange. Here's another example. A university contract might have the condition faculty must live on or near campus. Asterisk, footnote. For the purpose of this condition, near campus shall be within 20 miles of the main building. It's a completely natural, ordinary kind of thing that you find in all sorts of legal contracts. There's nothing weird about just making a ruling. When you've got a vague predicate like near, just make a ruling. What's to count as near? Here's a question about whether there might be different kinds of vagueness. Again, this is one of the things I just wanted to set people thinking about some things, including things we're not going to talk about. I'm afraid this is one that we're not going to carry much further, but of course we can in discussion. He arrived at noon counts as true if he arrived a few seconds after noon, and we have some inclination to accept the following theoretical principle. Given that he arrived at noon is true if he arrived at precisely t, then it is true if he arrived at t plus a tenth of a second. Some inclination to think that. It seems arbitrary at any rate to say a tenth of a second can make a difference between whether or not he arrived at noon. But it's not clear that noon is vague. It's not clear that the right explanation of what's going on here is to say that noon is vague. The right explanation might be something more like noon is precise, but we're happy to use it in a rather loose way. Now, it might turn out that this is a model for something like bald. And perhaps rather like noon, bald applies precisely to those with no scalp hair, though we typically use it rather loosely. If that's so, then two of the most common examples of vague predicates, bald and heap, actually fall in different categories. Certainly, these things like bald and noon seem different from young or heap. Well, context is going to be some things one of the aspects we're going to look at most carefully. Tall in a context in which 4-year-old children are salient has a different extension from tall in a context in which adults are salient. No one has ever disputed this as far as I'm aware. On the other hand, vagueness remains when such features of context are fixed. The extension of tall in a context in which 4-year-old children are salient still doesn't seem sharp. So that's one feature of context to notice. It's what Rathman calls external context. And I think it's indisputable. And an anti-contextualist theory of vagueness will not dispute that kind of effect. Now I think of force. I'm so sorry. So
I just would like you to explain the second bullet again, because I'm not sure I fully understand it. Could you give an example of such context?
So you've got a class of children, and they're all 4-year-olds, maybe. And somebody says, well, which are the tall ones? And 3 of the children differ in height by just 0.5 millimeter or something. You can barely measure it. You need some sort of laser device even to look that. And now somebody says, but look, you can't count all of them as tall. But you don't know where to draw the line.
Okay. So the argument is that tall is still vague no matter whether it's in a context of 4-year-olds or in a context of basketball players.
Yeah, exactly. Of course, how tall you have to be will be very different in the two contexts. But in both contexts, there may be no precise answer to how tall you have to be to count as tall. So force-marked varieties are really interesting. They're going to play a prominent part in our discussion. The idea is that the phrase was coined by Terry Horgan, although the idea was present in the literature before. The idea is this: you expose the subject to say the first member. You can do it in one of two ways. One way is just to expose the subject to the first member of a Sorites series with everything else blanked off, elicit a response from that person, then expose the person to the second member of the Sorites series with the first member still visible and elicit a response. And so you're being force marched down the elements of a Sorites series. You can also do it with colors, you can do it with pairs, you can look at the first pair, or that both those are red, aren't they? And you've just judged this one on the right to be red, so now look at patch 2 and compare it with patch 3. You can't tell any difference in color, and you've just judged patch 2 to be red, so what can you do except judge patch 3 to be red also? And you can see that when you're in that kind of situation, there's a strong tendency to go on applying the relevant predicate beyond what might seem sensible. So this is a contextual effect which is of special interest to us, and we will be discussing this quite often during the course of these classes. We need to consider, and really, in a way, the difference between the contextualist and the anti-contextualist on this point is whether what happens in forced marches needs some special reflection in the semantics of the predicates in question. So here's the first course characterization of the contrast between contextualists and anti-contextualists about vagueness. Contextualists believe that understanding the nature of vagueness requires understanding a distinctive way in which context affects vague expressions. And anti-contextualists can agree that vague expressions are context sensitive, but they hold that this context sensitivity does not explain the nature of vagueness and is not distinctive of vagueness. So here are some questions about Sorites. This is really going to be very much at the focus of our discussions that a theory should address. If the inductive premise can't be true on pain of contradiction, then should we say that it's false? If we say it's false, then that seems to give us a sharp boundary. And if it's not true that each object, if an object in the series is P, then its successor is also P, then presumably there's a last object in the series which is P. Then that last object will be the right marker, so to speak, the boundary of P-ness. So how should semantics address that? And if the inductive premise is false, why can't we provide a counter instance, an object which is P and whose successor is not P? Why are we so inclined to accept the inductive premise? And a related question, why are we so inclined to drag out our affirmations in forced march situations? So I think it's also striking, as I mentioned when I showed the Sorites series of patches, even in full knowledge of what's going on and independently or seemingly independently of context, each material conditional strikes us as true. And there's a question whether that can be explained in the same way or in a different way as the explanation we give of our attachment or our inclination to accept the inductive premise. So I'm just going to give a list of things that need to be accommodated in an adequate account. It's probably not an exhaustive list. Anyway, we can't, 50 years ago, people were inclined to the view, or at least they contemplated the view, that we should just get rid of vague vocabulary because it was a nuisance. It didn't fit into logic, and anyway, who wants to be vague if you can be precise? But that attitude has now evaporated. I don't know anyone who takes that kind of line. So vague words are here to stay. They are actually valuable and useful to us. We need them. So there must be some coherent semantic account of them. The next thing we have to digest is the structure imposed by an underlying relation. For example, we have to do justice to such principles as that anything taller than something tall is tall. We have to account for Sorites paradoxes. That's say we have to show how there are no Sorites paradoxes. And we, in that connection, need to attend to the attractiveness of paradoxical versions of tolerance and our tendency to overextend in forced march situations. We need to explain why we can't locate cutoffs. We need to explain the acceptability of local specifications like the paint shop proprietor or the university administrator setting up a contract. Shapiro calls that open texture, taking that phrase from Weissman from the 1940s. Something I haven't mentioned, we're not really going to get round to this, which is a pity, is the role of approximators and hedges, things like fairly and somewhat, very, which clearly can affect vague predicates in particular rather interesting ways. Higher order vagueness, we can't avoid saying something about that. As I said, our main focus is going to be on context and the impact of actually conversational presuppositions and other contextual factors.
I do get the difference between vagueness and higher order vagueness.
So let's say the lowest order of vagueness, let's call that first order vagueness, is between, say, the bald things and the things that aren't bald. Then the next order of vagueness is the vague boundary that appears to exist between the things that are definitely bald and the things that are borderline cases of vague vagueness. And that gives you a hierarchy that has no upper bound, and you can just go on iterating that thought. So it's conspicuous in supervaluational approaches. Maybe we start off by thinking that a predicate has a positive and a negative extension, and the union of those exhausts the domain. And then the supervaluationist comes along and says, no, there's this penumbral extension as well. There are 3 extensions involved. But we still seem to have these sharp borderlines between the positive and the penumbral and the negative extension. And somebody might say, well, there shouldn't be a sharp borderline here. Somebody who says that is responding to or trying to put on the table a conception of higher order vagueness, that there needs to be vagueness between the positive and the penumbral as much as between the positive and the negative. We can have a moment for discussion now. The last slide is just some reading. This is really I'm not sure if I can quite justify why I put these particular things on the reading list, but for the next class, the things that are actually going to be discussed, that will actually be, I think, mentioned by name, will be Kamp's 1975 paper, Vagueness, Truth and Logic, Kamp's 1975 paper, 2 theories about adjectives, and Shapiro's book, 2006. So in fact, the Kamp and the Shapiro are in my Dropbox thing that you can access, and the file's easy enough to get. Can anyone remember the journal? Synthèse. So you can get it from any online source. So we've got if people wanted to ask questions, I'm sorry, I probably wasn't very good about taking questions as we went along. And sorry, I know that I didn't notice some of these questions. So we've got a couple of minutes now. There are things people want to ask before I hand over to Hans. So, yes.
Professor, I have 2 questions.
Yes.
So, from my understanding, a substantial number of philosophers tend to characterize vagueness in terms of borderline cases. Mm-hmm. And you only mentioned borderline cases a single time. So I was wondering, A, why you and Professor Kamp felt that this susceptibility to theoretical series was a better criterion for vagueness, and B, how would you characterize borderline cases under your view?
Well, I have to say, in an earlier version of these slides, I started off by saying vagueness is characterized by borderline cases, and then the next slide said, what is a borderline case? And 10 slides later, I hadn't really quite tidied it up. So I thought, well, maybe this isn't the place to begin. There are a lot of ways of trying to characterize what a borderline case is. So, I mean, one way would be neither definitely P nor definitely not P. And so that got sort of mentioned en passant. Another way would be perhaps in terms of unclarity, or so I'd said that wasn't. So some people, Wright at one point says borderline cases are ones where we can have faultless disagreement. I wasn't sure if that was right. Anyway, so I have nothing against it, and it does seem to me right to say that if you've got vagueness, you've got borderline cases. It's just that then the question of what is a borderline case is quite substantive. It's not clear that it's a less substantive question than the original question, what is vagueness? So it's only that sort of pragmatic reason. Did I see a question right?
Yeah, I should. It's not really a question. You mentioned this example with the guy with the chains, right?
Yes.
So it just occurred to me that if this if he had put, say, what was it between yellow and?
Well, red and orange was,
Well, whatever.
yeah.
So, I mean, it would have been totally wacky had he put the border between yellow and orange somewhere in the brown region or whatever, right? Somewhere, nowhere near these colors. But suppose he puts it somewhere right in the middle of yellow, right? That's not so, I think that's not so bad. It's up to him, right?
Mhm.
So that's I have this intuition, and that's so, maybe one shouldn't explain too much here, right? So this is about higher order vagueness one thing. Maybe one shouldn't explain, but maybe the region of yellow, right, is very, 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 very small, right? See what I mean? And
Yeah.
anything, beyond that is sort of, up to the user, right? To the context of negotiable. That's basically right. And I wouldn't call. I mean, it's strange that he puts the border in between there, right? I would call both of these on either side yellow, but then he might point. Well, I mean that goes for almost wherever I put it, right? I mean, that as we know, right? And once you see that, well, yeah. If you need to make some kind of, if you need to make your borderline precise, right? It doesn't really matter where it is, as long as it's not kind of really wacky, right? Off the mark, whatever, right?
Yeah, I agree. There's going to be indefinecies about the circumstances in which it's proper to make a cut here.
No, what I
But
mean
it's-
is, one could try to get rid of this problem of higher order vagueness, right? If
Yeah.
Yeah. Just by this kind of consideration, it's really, what you need is really very, very small extensions and anti-extensions, right? And then you have huge a range, and maybe within that range, right, many decisions would be completely arbitrary. But it's like, well, yeah, that's it, right? Arbitrary just then means it's socially unacceptable sometimes, right, to put the border, and it gets acceptable in certain contexts, right, like this guy with the things. That's why I thought is yeah, it gets more acceptable. It's up to, I mean, in a sense, it's up to him anyway, right? It's his shop, right? And
But it's not his word. It's our word.
no, that's what I mean. He's using the word, it's still using the word yellow. I mean, it still makes sense that, and especially after he points out that the decision is arbitrary anyway, right? Yeah. As long as he doesn't make the borderline somewhere beyond what's
Yeah.
yellow, right? That's just a possible position. I thought.
It's arbitrary within limits, and then one could discuss what those limits are. So I think we're essentially in agreement. And your point may be that there's a higher order vagueness issue about what the limits to the area of arbitrariness are, which I think is probably correct. Nice.
Suppose you had a predicate F such that it was indefinite whether it had borderline cases. That predicate F would admit of Sorites susceptibility, but if it were indefinite, there were borderline cases, then it would be the case that when a predicate is vague, it automatically has borderline cases. So I think there may be a further issue about, this relates to the first question about how Sorites susceptibility and borderline cases relate to one another.
Yeah, I
have an
agree.
example in mind, say.
Well, so suppose you thought that what about the predicate true? This is gonna get complicated.
Yeah. No, I'm happy with the thought that the borderline casing may not line up. It certainly doesn't line up in the other direction because remember that example in Fine in which he defines child as somebody under 20 or something, and then or it's child star under 20 you are one, and over 21 you're not one. And that leaves a borderline area, but it's completely sharp borderline area. So in that case, you've got the inverse case. You've got borderline areas without vagueness. So yeah, so I think we're better off with the theoretical characterization. I'm trying to make the camera work for Hans. I'm not quite certain why I haven't succeeded. So I put your first picture and from my copy, but you might want to just note that you can zoom. You can zoom around. Look at this.
Oh, God, oh, you took the thing away.
Well,
Yeah, it's not at all.
Reserve your own copy.
Right, exactly. And, right, I haven't actually done this, but it sounds fun. So, Mark said, I was supposed to do the hard work. I think of it more as the donkey work. Now, donkeys sometimes work very hard, or made to work very hard, so there's no real contradiction there. But certainly today, and that's even going to be, I'm going to spill over into tomorrow. True to some extent also when it comes tomorrow. We will start out in a very pedestrian way, and I blush when I see some of my colleagues here because they're terribly, terribly bored. But we do think, I think we both think that certain questions can in the end be discussed, even if they're fundamental philosophical issues. They can be discussed better and perhaps only against the background of a certain amount of formalization. Some of this formalization goes back a long time, and what I'm going to talk about today is mostly just that. So it may be familiar to all of you, but we have to somehow set some kind of, or build some kind of formal setting within which and against which we can then also discuss matters in a more, say, conceptual way, or from a more conceptual point of view. So, what this part of the course, part 2, is going to, can you read this? No.
Can you make this bigger? Could be made bigger.
Yeah? I mean, the light is not very good, is it? I can switch to a computer, that's better.
Take too long.
Huh?
Take too long.
Take too long. Okay. You'll have to read it, we'll put this online. So, I'll start very conservatively with a model theory for language that has just one place predicate that's vague, everything else is not vague, but those familiar with this literature will know, as soon as you actually add one vague element to the language, that radiates through the entire language in as much as it affects the recursive or compositional part of the semantics necessarily, because when you have a complex expression with some vague constituent somewhere in it, that may produce lack of definition and definability of values that then somehow have to be dealt with in some way or another when you see how that constituent combines with other constituents, and so all the way up. So that's the first thing we're going to do. Then, again, still very old-fashioned and conservative, we're going to extend this partial model theory to the way in which people have standardly dealt with supervaluation. That is, these partial models that we get for our language with our one vague predicate P will be the kind of core or basis of a larger structure in which there are, besides this base model, a large number of non-vague extensions of it. And we'll see what we're going to do with that. Part of that, or the next step, is actually modification that looks sort of plausible and trivial at first, but actually is going to have quite interesting consequences where you say, I don't move in one go from my base model, my partial model, to these complete extensions in which all elements of vagueness concerning P have been resolved. So these are then classical models. No, that's a very unrealistic picture. In as much as we can reach such models at all these complete extensions, typically that will happen stepwise. The kind of sharpenings that normally occur when people resolve borderline cases of vague predicates, that's a kind of piecewise or bit by bit procedure. More cases get decided, but typically there will always be borderline cases still remaining. So you get these chains of extensions of sharpenings that perhaps in the end will lead to complete models. Then we'll look at how we can formulate, or should formulate, a Sorites paradox, so that we can really discuss in some detail exactly what kind of account of why this looks like a valid or sound argument, but in some sense isn't, how that could how these arguments can actually be given. And so the supervaluation theory will then be used for that purpose. And then we'll say a few words if there's time about adding determinateness that leads into the question of higher order vagueness. If there is time, but there may not be, there's also something I'd like to say in this connection about the role of semantics, and in particular moral theoretic semantics generally. So that's the program. Today we'll probably not get beyond about here. I hope we'll get at least that far. And let's start. So the beginning is really, for anybody who knows, can I count on people being familiar with the basics of the moral theory of pretty good logic? I mean, if you don't know that, it's going to be pretty fast. I hope you'll still be able to understand some of it. But so, before we actually get to vagueness, our basis is going to be just a language of first order logic with non-logical constants that are individual constants, predicate constants, functions. We need one function at one point. For reasons that will become transparent only on Thursday, it's actually when this is the basis for the development of the theory, moral theory of vagueness, it's rather important to not kind of adopt from the start presumptions of the interdefinability of logical operators. It might be that, you know that classically you get pretty good logic just with not and existential quantifiers say, but we don't want to do that. So we want to take all the standard operators of logic, not and, or, if, then, and the two quantifiers as primitives, means, of course, that the truth definition is going to look terribly prolix, but it's not that bad. And so that's basically what the language is going to be like. The models, here they are defined, but I take it to be well known. They consist of a domain of discourse, D, and an interpretation function that assigns sets, subsets of D to one-place predicates, and so on. So there's the definition of leave it what it is. And then I think it also be familiar how you define truth for this language, L0, in models of this kind, and we're not going to go through the whole definition. There's just one thing I want to point out, again in connection with the extension that you're aiming for when we throw in the vague predicate P. As soon as you throw in P, then things get partial. There will be formulas that just don't get the value, true or false, in the model. And so then it becomes important that even for the operators that we have in classical logic, the truth definition is, the truth clauses are split into positive ones and negative ones. So that's what we've got here. So for the atomic formula, something like Q of A1 up to AN is true if and only if the values of the terms A1 up to AN form a tuple that belongs to the extension of Q. And we also, actually for this particular, the atomic clause, it doesn't matter too much. We have this further clause that says, well, when such a formula is false. And then it's going to be important for all the operators. We have these double clauses. Negation is true if the negated thing is false and the other way around, and so on. And so particularly important, as we'll see, for the binary connectors, for instance, the conjunction is going to be true if they're both true, and it's going to be false if one of them is going to be false, and so on. So, then, we can leave that for what it is. So logical consequence, you probably also know, that's something that actually is worth discussing, and the stuff about semantics at the end is meant to say more about that. But you all know it, that's the beauty of model theory. Model theory, model theoretic semantics, you actually have a conceptually clear, natural notion of what it is for one formula to follow from other formulas. It's the case if in any interpretation, in any model in which the premises are true, the consequent will be true as well. And logical truths are those formulas that follow from the empty set of premises that are true in all models. So, now, how are we going to extend this language and its model theory? Well, the language is simply extended now by throwing in this one place prefix P. How are we going to extend the models for the language? That is, how are we going to deal with the semantics of this predicate P in such a structure, which consists, basically, as far as P is concerned, to start with just of this domain T. The simplest notion is there are certain things that we know, in the situation described by the model M, are known to be P. There are other things that are known to be not P. There's an extension and an anti-extension, but there is also a range of borderline cases. This really is a borderline case semantics, or motivated semantics. There are these cases where it's indeterminate whether they are P or not. And the simplest way to model this is to simply have this tripartite division of the domain of discourse. There's the extension, there's the anti-extension, and then there is still the stuff in between, which we call the truth value gap of P in the model. So the interpretation function now gets extended for P to, it will give us these two extensions, the positive extension and negative extension, the anti-extension. And as with no sharp predicates, these are of course disjoint, but the difference is that their union in this case need not make up the entire domain. So when we extend these models in this way, we had in an interpretation for P of the kind described, and of course the truth clause for the atomic sentences involving P, A is P, will be what you would expect. PA is going to be true if A belongs to the positive extension, it's going to be false if it belongs to the negative extension. If A is neither the positive extension nor in the negative extension, then we get something undefined. And as I said, that then can percolate through the entire truth definition. That's why we set up the truth definition in the way we did. And So what we get now is a partial truth definition. We get the situation that there will be sentences and models, such as the sentence in a model is in a model neither true nor false. And if we define logical consequence in the way we did, A follows from B, in all models in which B is true, A is true, then that definition also is going to be affected by this modification of the semantics. Now, we now have a situation where A in a given model or B in a given model may be either true or false or undefined, and the same thing for A. So we may expect that the relation, if we still define it in the way we did, in every model in which B is true, A is true also, that relation actually will pan out differently, that the relation holds between different formulas. So, in fact, when you look, this is also work that's been done a long time ago, when you look at what you get as logic from this definition, this partial definition of truth, together with the classical definition of logical consequences whenever the premises are true, the conclusion is true. You get a different logic. It's known as strong Kleene. It's sort of logic that Stephen Kleene, a mathematical logician, who formulated a long time ago for totally different reasons, although there is some connection has to do with his interest was in recursion theory. Well, I don't want to go into details right now of that logic, but it is a weaker logic than classical. Oh yeah, in particular, I mean, that should be, that's one way of bringing out very clearly what one of the differences is. You don't get any logical truth anymore. There's no general pattern for E. There's no schemata like A or not A that are going to be true in all models. Why not? Well, take a case where A is P of A, P of D, and not A is not P of D. If D is in the truth value gap of P in a model, then neither the first disjunct nor the second disjunct will come out true. So this junction will also not come out true. It will be undefined. You get undefinedness all over the place, so logical truth in that standard classical sense of true everywhere, you don't get them. You only get them for the formulas that don't contain P. So that is a first attempt to make some sense, full sense of the semantics of a one-place predicate. And one kind of logic that comes out of it, and it's not classical. And the question that a logician would, of course, then immediately ask, if he also has some philosophical interest, is that really right? Is that the last word about the logic of vague predicates that we can say? And the answer is multiply. No. It's not the last word for a whole lot of different reasons. And one way in which we can try to argue that you can do better, or at least differently, is by saying, well, we shouldn't, when we try to think about the logic of languages with vague predicates, just focus exclusively on these partial models. These partial models give you a sort of situation in which there's this positive extension and negative extension, and there's the gap in between. But there is some kind of dynamics, you might say, involved in vagueness insofar as undecided cases, insofar as borderline cases can be resolved one way. And you might say, well, when we reason with vague premise and vague conclusions, one attitude we can take is that even if there are truth value gaps for the predicates that occur with our premises and conclusion, we can sort of take the line, well, as long as it is the case, no matter how these undecided cases will or would be resolved, the truth of the premises will entail the conclusion. That's in a way good enough. That's not an implausible line to take, especially if you think, as we know, I think a lot of us do, perhaps everybody in this room, that the languages we speak are riddles with vague predicates. There's hardly anything that's not vague. And these vague predicates very often occur in quantifications over domains that we can't even completely survey. So borderline cases sort of are all over the place implicitly in what we say and think about and in the inferences we are trying to draw. So the intuition is, let us try to formalize the idea of an inference is valid so long as any of the possible ways of resolving the ambiguity, the borderline cases, lead to a situation where both the premises and the conclusion do have a truth value, and where the truth of the premises always will guarantee the truth of the conclusion. It's that kind of notion of logical consequence that we might want to capture. And the way in which that was originally done was to say, well, this is the fundamental idea of supervaluation. Suppose I have a vague or a partial model with a vague predicate P. There's any number of different ways in which I can resolve the truth value gap of P in M. Any one of those ways, any full resolution, will turn this model into a classical model, and it's about those classical models that I want to reason. So, what do? We take our vague or our partial models to be the core of a model structure, so-called supermodel, in which we have, in addition to that model, a whole lot of complete extensions of it. These are classical models. We say our premises, on premise B, entails A, or A is a logical consequence of B, just in case for any such structure consisting of a partial model with its maximal extensions, as long as in each of these maximal extensions B is true, A is true as well. Now, this is of course just a way of getting classical logic F, and indeed that is precisely what we get. So the model structures, the supermodels that we want to look at now, here, the supermodel is just a pair consisting of a partial model, and the stripped N is a set of maximal completions. And the definition of logical consequence now is that one that involves just these maximal extensions. There are two ways in which you can do it. One is the global definition, and one is the local definition. The local definition is the one that I already described. We say that, well, here it's a set of sentences gamma has as its logical consequence a sentence phi if in each such structure it is the case that in each of the classical models in N, if the psi's are true, then phi is true. The global definition actually talks about not just these local truth values of premises and conclusion, but rather about a notion of truth that we can define once we have structures of this kind, and namely the notion of a formula being true in such a structure if it is true in each of these maximal extensions in script N. That's called supertruth. There are people who think that supertruth is a natural notion to replace the notion of partial truth when we talk about vagueness. We can discuss that. If you think about supertruth as the new notion of truth, then the global definition is the natural one. Gamma has phi for its logical consequence if in all such structures, if the premises in gamma are supertrue, then phi is supertrue. As it happens, the actual logic you get in either case is the same. You get classical logic not only here, but also there. So that's the situation as far as just the outline of the supervaluation theory is concerned. To the extent our core models with these maximal extensions, and these supermodels then give us a basis for, in particular, defining logical consequence relations, logics in a certain way. Now, so far we have actually assumed, I'm just giving to this section on penumbral connections, we have assumed that there were actually no constraints. What time do we stop? No constraints on the vague predicate, other than that it has this tripartite extension. But when you think of vague predicates that you find them in natural language, that's actually not very natural. The classical examples, not all of them, but a lot of them, of vague predicates in natural language are adjectives. Many of these vague adjectives are actually capable of being turned into comparatives, taller than, rather than, and so forth. The information that's made explicit by the comparative is something, and in a way, of course, you should say, is already there in the concept that is expressed by the adjective, whether you use it in the comparative form or the positive form, whatever. So that means, in particular, that among borderline cases, two objects D and D prime, neither of which is clearly red or clearly orange, it might nevertheless be the case that one is more red than the other. And if we use language L with this predicate P, if we use P, so to speak, to formalize or analyze or study the behavior of a vague predicate like red, or tall, bold, and so on, what we really should take into account is these so-called penumbral connections between the objects that may both be in the borderline area, and which will mean that if we resolve the borderline area in a certain way, we try to resolve it, we are under certain constraints. If D is greater than D prime, then we cannot actually put D prime into the positive extension of the predicate red without doing that also with D. So we actually, at this point, have a kind of different ways of using this very simple model theory as so far sketched. You can use it to study the phenomenon of vagueness in its very general sense I was talking about so far, and use it to get some kind of handle on the logic of vagueness, that we just look at arbitrary structures of this kind with a partial base model and a number of maximal extensions. But we can also use it in a situation where you take P to represent some particular vague predicate, which will come often with special kinds of constraints, which will manifest themselves in what kind of maximal extensions can go into N given the base model. What you get in such cases, the good models that is, the good supermodels will have an M and some selection of all logically possible complete extensions, and it is that subset of the total set of possible extensions that reflects these peduncle relations between, say, the D and the D prime that I was talking about. And so when we use this model for this kind of study, actually we don't study so much just the logical vagueness in general, we study the sort of semantical logical properties of such a particular predicate, and the limitations that, so to speak, come in that only some such supermodels are admissible now, will of course then also have an effect on what kind of so-called logical truth you get out when you apply the definition of consequence on this special set of supermodels that reflect these penumbral relations, connections for this particular predicate. And so I don't want to go into detail about that right now, but one possibility, it's not perhaps completely defensible for various reasons that in the interest of time I don't want to go into, but one possibility you might have is actually now to use this highly structured set of supermodels for this particular vague predicates to explicate in what way the predicate itself, say red or tall, already forces upon this entire structure the relations between objects that become explicit when you use the comparative. In this 75 paper, there was an attempt to actually define a Kamp operator operating on such vague predicates as red and tall in a way that is spelled out by reference to these supermodels. And the truth conditions for, just put it here, not in order to go through it in all detail, but so the truth value here of P bigger, X is bigger than Y in a ground model or base model M, a partial model is then defined in terms of what the relations between X being P and Y being P are in the members of this set of maximal extensions of M that reflects the penumbral relation between the X and Y. And if the penumbral constraints on P actually are one-dimensional, in a sense spelled out here, means that take any two objects, then either one is at least P is the other, or the other way around. Then what you will actually find is that this relation here, this relational predicate on P is going to be a linear order. Just makes that penumbral relation between the objects in the extension of P explicit. There are various difficulties with this analysis, and one is that, of course, you also have to do something with cases where both D and D prime are definitely red, and still one is more red than the other. And so you must assume that context relates a little bit, perhaps, to what Ada was saying before, that context actually can change the extensions of predicates more than you might normally assume, but there's very little by way of a fixed, universally fixed, minimal extension and anti-extension before that word like red or yellow. But that is true, is debatable. But so that's the general line of this kind of work. It's the structure of the supermodels reflecting a particular vague predicate that carries a lot of information about the penumbral relations or connections for that predicate. There are also penumbral connections between predicates. Fine discusses a case of red and pink. Something might be on the borderline red and pink. So in a supermodel and a maximal extension, you either put it into the red extension or the pink extension, but of course then you may have two things where this one is a little redder and a little less pink than that one. So again, that puts a constraint on what the supermodel can be like. So much, and it's very sketchy, I agree, for what you can do with these supermodels. Very briefly, and actually continuing some of the ideas already formulated, a modification of this very simple idea, a model simply a partial model and then all these complete extensions, is that sharpenings, specifications, proceed step by step. And so what we get now as a model is not a supermodel of the kind described, but something that looks just the same, but where now the N consists of models that themselves also may be partial. They may be sharpenings of the ground model, and of course some will be sharpenings of some other things in here. And so what you get is actually a partial structure now, ordered by this model is an extension or a sharpening of this one, with the partial model, and you might say as a sort of base, as a kind of root from which this partial ordering emerges. So it's not a tree because things can come together again, but it is a partial ordering with a minimal element. Now, there are various ways in which you can think about such a structure. One is that you think of these partial models in N as just sort of, well, steps towards a complete removal of all the vagueness. And if you do that, you might actually want the structures we're now talking about, these specification structures, to have the property. If you take any branch in this partial ordering, any maximal branch, so, or chain of sharpening, starting with M and going as far as it will go, then that the limit of that branch will always be a complete model, a model in which all borderline cases appear being resolved. And then you can use these specification structures in much the same way we used supermodels before. That's not particularly interesting. But you can also think of these sharpenings in N in a more concrete way. For instance, as corresponding to particular contexts in which we use the predicate P and were, for whatever reasons, we still have to talk about those, some of the uncertainties appear being removed, but others still remain. So one interpretation of these specification structures that we're going to pursue is that they are the reflection of a situation where we have a kind of base model that, at least in the sort of setting that we are now using the predicate P in, gives us an extension and anti-extension which are kind of irrevocable in this situation, but then the context can modify that minimal situation by putting some of the objects in the borderline area into the positive or into the negative extension without doing more. So you get a structure, roughly speaking, of contexts, or the reflections thereof for the semantics, that have the property that some context can modify or emerge from another context. And it's this kind of dynamics of context that we want to pursue at greater length in on Thursday. For now, I only want to point out something, and we have to end, and that is that when we have these kinds of partial structures as here, then anybody familiar with the semantics of modal logic will say, looks very much like a Kripke structure. You can think actually of this M as just as one of the many partial models, so it might also be part of this, just take it to be part of this set, and for the set of these partial models for L, they stand in this relation, this partial ordering or sharpening. And we can think of the sharpenings n prime of some other model n as, so to speak, corresponding to context that can be reached from the context represented by n. And once we see these structures in this way, it becomes very tempting, certainly for somebody who's familiar with how modal logic works, to say, well, perhaps actually, once we are prepared to think of these structures as reflecting the semantics of P in a natural way, the logical operators of this language of which P is part might be revised, or others might be added, which make use of this partial ordered structure in the way in which intentional or modal operators make use of the space of a structure, a set of possible worlds with an accessibility relation between them. Now, this sounds, as I put it like that, just like sort of a game, and we know how to do this, we might try to do that for vague predicates also, but on Thursday I will try and make this not just a formal possibility, but try to convince you that there might actually be something in it, given our intuitions about how vagueness works and how it interacts with the context. So I'm afraid we have to stop here. I'm sorry I didn't leave any time for questions. since I'm continuing tomorrow with this, I propose that before I start, I give you an opportunity to ask some questions. There will be then also an opportunity at the end, but so that's at least to make up for my failure to stuff like that. So the next thing then is formulation of the Sainsbury paradox and what you can do with supermodels.